Hi, welcome to this technical overview of what's new in IBM Spectrum Protect version 8.1.11, IBM Spectrum Protect Plus version 10.1.7, and IBM Spectrum Copy Data Management version 2.2.12. My name is Tricia Jong, and myself and my colleague Sean Sperry will be covering the new features and functions in both Spectrum Protect Plus, and CDM. These announced on November 18th, 2020 and GA on November 20th, 2020. The first new feature in Spectrum Protect is the ability to utilize our S3 API to protect any S3 application. If you remember back in version 8.1.7, we introduced an object agent and object client to enable the protection of Spectrum Protect Plus out to Spectrum Protect container storage pools via this S3. And then in 8.1.8, we introduced the S3 copies from Spectrum Protect Plus via S3 out to Spectrum Protect tape. Now in version 8.1.11, we're opening up that S3 API to be used by any type of S3 client application to be able to do backups and restores from the Spectrum Protect container storage pools. So this will expand the workload that we support by enabling any S3 capable application to store directly to that Spectrum Protect ecosystem. And it opens up the Spectrum Protect storage services to these modern applications that require specialized application integration but work with S3. I do have a YouTube on going through the setup of this, but it's actually very simple. As long as you've set up your storage agent on the Spectrum Protect server, and there's one storage agent per Spectrum Protect server, and then you've started up that object agent services on the Spectrum Protect server and registered one or more object client. Now you can't have multiple object clients per Spectrum Protect server, and usually you'll have one of those object clients for each of the S3 applications or Spectrum Protect Plus servers that you're backing up to the Spectrum Protect server. And then on the application, in this case we're going to use AWS S3, but you could be using any different type of client application. You're basically going to go through and add in the ID and secret access key that was generated when you defined the Spectrum Protect object client for it. You're going to create a bucket to use with Spectrum Protect on AWS, and then you're going to go ahead and issue S3 commands to copy over the files you want to the Spectrum Protect Plus server. So the S3 applications that we support must support and use the S3 API calls and parameters that we documented in our Knowledge Center. So these are pretty standard, but do take a look at it to make sure whatever S3 application you're looking to protect fits that criteria. Now you can utilize Spectrum Protect container storage pools, either directory or cloud, to store these S3 objects on. Currently, the Glacier copy to tape via our S3 is only supported for Spectrum Protect Plus. Spectrum Protect supports multi-part uploads and range reads, and S3 client applications are currently only able to access the active version of a file. The S3 data can be replicated to another Spectrum Protect server, but in that case you would have to do a manual changeover for your S3 client to the next one if there was a failure. It doesn't do an auto failover. Now one thing I want to point out is don't confuse this S3 support with our back-end S3 support that we have for our container storage pools. These are not related, other than that they use the S3 protocol. And also, when you're setting this up, don't set up a cloud container storage pool and point it at an object agent. That'll create a loop and you won't be happy with the results. So do check out the YouTube I have on this case it was sending an AWS S3 client out to Spectrum Protect server, but you could utilize it for any of the different S3 applications. So the clients that we support are obviously IBM Spectrum Protect Plus, and then any other S3 client application that uses the subset of the S3 API that we support. On the Spectrum Protect server side, the objects are going to be stored to an object client node that you're going to have to define, and those are stored inside of Spectrum Protect server as backup objects. We don't support archive objects or space management. So the domain that the node is going to be assigned to must have a backup copy, but it doesn't require an archive or HSM copy group. Only container storage pools are supported for the object data, and that could either be a directory container or an on-prem or off-prem cloud container. All the objects are going to be uniquely named, and there's never going to be an inactive version of the object. So when you set up the protection, you only have to have version data exist set to 1. And because there are never any inactive objects, the retain extra and retain only settings can be 0 days. The Spectrum Protect server does not control which objects are deleted. The deletions are going to be driven by the Spectrum Protect server and the apps. And to allow this deletion, the object client node must be set to allow backup deletion. I mentioned in the previous slide that we support multi-part objects, and the way that this will look on the Spectrum Protect server is that the client is going to initiate that multi-part object request, and the head object is going to be first sent to Spectrum Protect, and then it's not viewable as an object to the S3 client. It's simply shown in the S3 list as a multi-part upload. The client put part, this is how the client sends the multi-part data, and each of those parts needs to be 5 megabytes or larger, except for the last part. And we're going to continue to put however many times that are needed, and S3 is going to allow up to 10,000 parts, up to 5 gigabytes in size. The client sends complete multi-part upload requests or aborts the multi-part upload request. So if it is completed successfully, then the object will be complete and viewable to the S3 client to do a restore from. It will no longer be in the list multi-part uploads, and the S3 client has no view into the original parts, but those parts are going to be retained as individual objects in Spectrum Protect. So if you look at my demo, I show you how these objects look inside of Spectrum Protect itself. If that multi-part upload request is aborted, then everything's going to be removed, the parts, the group, and the head object. The next enhancement is the ability for Spectrum Protect server to use Google Cloud Storage as a off-premise container storage pool. And this will utilize Google Storage both as an container storage pool as well as a backup destination for the Spectrum Protect server metadata catalog. So this expands our cloud choice to include the Google Cloud Storage, and it's going to help efficiently manage storage by being able to tier data from your disk container out to clouds, and in this case you'll be able to choose the Google Cloud Storage. The setup for Google Cloud Storage is very similar to any of our other off-premise cloud providers. You're going to create a bucket in Google Cloud Storage, so you have to first log on to the Google Cloud Platform console, set up a service storage account with storage admin permissions, create a JSON key, and then create a bucket. And then you need to verify that the bucket service account has that storage admin permissions. That's very critical. Then you're going to copy the access information JSON file to the Spectrum Protect server instant directory. Don't change anything, leave it as it is. And you want to keep that JSON file safe, because if you're doing database backups of your Spectrum Protect server metadata catalog out to the Google Cloud Storage, we're going to need that JSON file in order to do restores in some scenarios. Then you'll want to create an off-premise container storage pool inside of Spectrum Protect, and then for the Spectrum Protect database backup, if you decide to go to Google Cloud Storage, then you'll need to create a connection for that as well. Do check out the YouTube I have on both setting up a container storage pool as well as backing up your Spectrum Protect database to a Google Cloud Storage. So in version 8.1.10 of Spectrum Protect, we introduced the ability to back up and restore the Spectrum Protect metadata catalog to Azure and S3. And so in this version, we're extending it to also be able to back up to Google Cloud Storage. The process is basically the same for the Azure and S3 cloud as it is for the Google Cloud Storage. You're going to go through the setup steps on the Google Cloud Storage, and when it comes to the DB2 native encryption, we're going to use that by default. So you're going to have to make sure you have that password to unencrypt the Spectrum Protect database using that DB2 native encryption. When we send the database backup out to the cloud, we also send the dev config files, the vol.hist files, and a master key file. So that's pretty cool because now if you have to do a disaster recovery, you have all of that information in the same location. This does not require a cloud cache on the Spectrum Protect server. We'll send directly out to the cloud without any type of caching. When it comes to restoring a Spectrum Protect database from the Google Cloud Storage, you can choose from multiple Spectrum Protect server database backups that might be stored in that same cloud. And then you can also have it bring back the dev config, vol.hist, and encryption files if those have been lost. If you still have those on site, then obviously you don't have to bring them back. The one key with Google Cloud Storage is if you do lose that .json file, which is your key file, if you can't find it anywhere else in your system, you're going to have to go through Google Cloud Storage to recreate it and then download it to the original location it was on your Spectrum Protect server. So check out the videos I have on using Google Cloud Storage to protect your Spectrum Protect database. In the Spectrum Protect Operations Center, we've now added visibility to tape volumes and device paths. Previously, tape drive and tape library management was visible in the Operations Center, and now with 8.1.11 you can also see the device paths, which will help. It'll specify the device paths, which are specific to library managers or to standalone libraries. You can also vary the device path online or offline from the OC, and you can drill down to get details on that device path. You can also see the activity log for specific device paths, so it will link you from the details out to an activity log for that specific device path. For tape library volumes, we show all the volumes that belong to a library. We also have some really nice predefined filters at the top, which will quickly show you volumes in a specific category. So for instance, normal, or volumes that are in a critical state or that have a warning associated with them, or perhaps the history view, which will show tapes that are no longer used by Spectrum Protect but showed up somewhere in a volume history file. We also have a media error view, which will show tapes that have media errors being reported against them. A not in library view, which shows all the volumes that have been checked out of a library. And a scratch view, which will show you the volumes that are in scratch. You can also view the activity log for specific volumes, so as you drill down on that volume, you can see the history of how it was used or if it was taken off-site or whatever else. Do check out the YouTube I have showing a demo of that new feature. Back in version 8.1.10, we added retention set disaster recovery manager for the tape management to the OC. And in 8.1.11, we've added the database backup volumes, tape copies, and retention sets also for the DRM tape management to the OC. So this gives you the ability to view and set the DRM state for your database backup volumes and your tape copies so that you can push those also through the on-site, off-site states that are popular with the DRM tool. In order to do this, the Spectrum Protect server must be at 8.1.11 or above. And if the database backup volume is to tape, it's going to be by default included in this on-site, off-site rotation. But if you do a database backup volume, for instance, that's to cloud, you won't see it in this rotation, which makes sense because it's not on tape. You will see valid media states automatically listed depending upon the current state of the volume. So for instance, if that volume is currently in a courier state, then it might be eligible to be put into vault or vault retrieve, but you wouldn't see it put into a not mountable state. You can utilize the Operations Center to move the data volumes back on site. It is assumed that the database backup volume would only be brought back in a disaster, and the active-only copy storage pools are supported just from the command line at this point. So check out the two YouTubes I have on doing DRM tape volume management from the Operations Center. One of the features I'm really excited about in this version is our copy container to tape and VTL. As you'll recall back in version 7.1.7, if you wanted to create a copy of a directory container pool, you would utilize a protect storage pool type equal local, and that would generate a copy of a container out to tape. However, back in version 7.1.7, when we wrote to tape for this protect storage pool type equals local copy, we left the data deduped, encrypted, compressed. And so in order to restore it, you first had to restore it back to a directory container pool, and then you could restore it to the client. In this version, we're adding a new type of copy out to tape, or VTL, and this is from a storage rule. And this is going to be a new storage rule with action type equals copy. And this will actually create a copy of your container storage pool. It will rehydrate that data and copy it out to tape. And so if a client wants to restore, they can restore directly from tape. So this is going to enhance your cyber resiliency by creating an air gap copy of your container storage pool out to tape or VTL. And it's going to give you quicker restores if your primary copy is lost or damaged, because you don't have to restore it to an intermediate location. This new type of storage rule, if you remember, storage rules are used for things like tiering. And so this new storage rule will allow for the on-demand or scheduled creation of a directory or on-premise cloud container storage pool out to tape or VTL. It can be scheduled via the storage rule syntax, or you could kick it off immediately with the start storage rule on-demand type of scenario. This will not work for an off-premise cloud pool. This is only for directory or on-premise container storage pools. All of the deduplication, server-side compression, server-side encryption is going to be reversed, and we're going to rehydrate the data on the fly as we write it out to the tape. However, if you had done client-side encryption, we will not unencrypt it before it's written out. Now, we will combine the rules and subrules to enable customers to choose what exactly should be copied down to the specific node level. So when you write these storage rules, you do have the ability to create a parent rule and then subrules underneath that. And we have a copy or no copy capability that you could use as the type of rule. And so perhaps the parent rule says copy everything, but then a subrule underneath that says, oh, but if it's Trisha's data, don't copy it. And so that just allows you to be very specific about what data in that directory container or on-premise container storage pool is copied out to tape or VTL. Now, if you also have a tiering rule in place for that container storage pool, that tiering rule won't occur until the copy storage pool has run. So these two kind of work in conjunction. So when you're going about scheduling, you want to schedule your backup storage pool to run in between your tiering to your target pool and your copy target pool. And that will then enable the restore storage pool on the tiering target pool to work okay. So tiering and copy storage rules cannot share a source pool if the tiering target is going to be an off-premise cloud pool. And off-site reclamation of copy pools might cause a data egress if that were allowed. Now, you can define multiple copy storage pools for a container storage pool. So if you did want multiple copies, maybe one out to tape, one out to VTL, you would simply define multiple copy storage rules for that same directory container pool. However, looking at the amount of time it takes and effort, you really got to figure that into your daily schedule and make sure you can accommodate that, especially if you're looking to do more than 2 copies from that source pool, because it simply might not fit into your daily window. Okay, I do have 2 videos on this. One is a demo using the Operations Center, and one's a demo using command line interface to create these storage rules action type equals copy. This is kind of what the command line looks like. Just if you're curious, you're going to define that storage pool with pool type equals copy. Then you're going to define a storage rule with action type equals copy or no copy. and define any subrules to go with that storage rule, so you can really specify what in that container storage pool gets copied out. In the Operations Center, you'll find everything underneath the storage rules, and then either create rule or create subrule. The next new feature in Spectrum Protect has to do with retention rules and retention sets. Remember, retention sets are where we take already backed up data and we make it into a long-term archive, which is a retention set. Previously, when you generated retention rules, you could specify members of that rule either by an individual client's name or a VM name pattern. In this version, we've extended that to also include node groups, client name patterns, and file space name patterns. And so this is going to allow you to add these different members or different pattern matching members to the retention rules. And you can also use the wildcards with the asterisk matching all different characters or the question mark matching a single character. A couple things to look out for is that selections can overlap. So for instance, if you're adding all file spaces and /fs0, both of those will include the /fs0 and both can be selected for an individual rule. Now, file space patterns are case sensitive and accept all valid characters. We do allow Unicode characters. And if a pattern is causing a client to be included that you didn't want to have included, you can't remove that individual client from that pattern, but what you can do is make up different patterns which would work around including that individual client. Okay, check out the short YouTube I have on utilizing this new feature. With retention sets, you can now delete nodes or file spaces from an existing retention set. Previously, you could only delete the entire retention set. So for nodes, you will specify the node or node groups to be deleted, separating them with a comma. And wildcards are allowed with node names, but not with node group names. For file spaces, you'll specify a single node when trying to delete that file space, and specifying the file space to delete by separating them by file space name with commas, and once again, no spaces. So if there is a hold on a retention set, then issuing a delete node or file space against that retention set will not work. We will mark copies on tape for expiration if you do delete something off of them. And we will maintain an activity log messages that you have deleted a node or file spaces. Those messages will be retained for the life of that retention set, and that's for audit trail purposes. Now this currently is command line only. Here we did a query ret set, and you can see the retention set contents out there. If we wanted to delete a single node, perhaps node 1 in this case, you could do a delete ret set 1, which is the retention set ID, and then node 1. And then it'll query you to make sure you want to delete it. And then if you went ahead and did the query ret set 1 again, you'll see that node 1 is now marked with an asterisk denoting that it's been deleted. Moving on to slide 15, with the Spectrum Protect server and client, we've added TLS 1.3 as our default for communication between the Spectrum Protect servers and clients. Prior to 718 or 812, SSL TLS communications was configured separately. And then in 718 and 812, we made the communication piece between the server and clients to automatically use TLS 1.2. This does not include encryption of the data, only of the communication between those entities. So now by default, we will use TLS 1.3. If you want to utilize TLS 1.3 in other versions of the Spectrum Protect server and clients, on the Spectrum Protect client side, you will have to add test flag enable TLS 1.3 in the DSM op file. And on the Spectrum Protect server side, you would add TLS 1.3 space enable in the DSM serve op file. And that would work with Spectrum Protect servers 819 and above. Okay, switching gears to HSM for Windows. We have added a web GUI for HSM for Windows, and this will help simplify the management into a single pane of glass for your HSM Windows configurations. So this HSM GUI will have a couple different screens to it. The first will be a dashboard, which will show you things like the number of file servers being managed, the amount of space managed, status of the service, maintenance tasks, and so forth. You can then choose some other tabs, which will include an activity tab, which would show you things like the file servers being monitored, the volumes, the use space, free space, thresholds, number of resident and stub files. The alert tab would be a centralized place for the admin log entries for errors or warning messages. And the configuration tab will allow you to control configuration and storage space, gives you information about the HSM installation, cluster status, version of HSM installed, no names, Spectrum Protect server, and if the recall service is running, as well as it allows you to set threshold migration configuration and then displays if that has been enabled. So in order to install this HSM for Windows Web GUI, it is a new component in the installer, so look for it as HSM client web file. There is a README document in there that documents the install steps. I also have a demo on utilizing HSM for Windows, as well as a demo on installing it. On HSM for Unix, we have some command line updates, which will help increase the scale in large environments where HSM data is distributed across hundreds or thousands of Spectrum Protect servers. So you now have the ability to specify a different password-dir per server stanza. So back in 8.1.10, the HSM client always used the password-dir from the first used server stanza only, whereas now in 8.1.11, the HSM client supports using different password-dirs per server stanza. We also have the ability to run DSM reconcile command on every HSM cluster. Back in 8.1.10, DSM reconcile command could only be started on the file system owning the node. And now in 8.1.11, DSM reconcile command can be started on every cluster node where HSM installed and when multi-server is enabled. So this is really going to help to allow to scale better in large environments where the HSM is being distributed across these hundreds or thousands of Spectrum Protect servers. And for best performance, consider starting the HSM operations like the migrate and reconcile by using Spectrum scale policies. So for instance, enabling the scheduling of migrating files, using the backup commands to protect that scale server, using the scale out backup and restore, which is called SOBAR and does DR capability on the Spectrum scale file systems, and then manually starting the HSM client commands. Okay, with that, I'm going to go ahead and turn it over to Sean to talk about some more of our TDP enhancements.
The next thing we'd like to discuss is Spectrum Protect for Virtual Environments Data Protection for Hyper-V. And what we've introduced in version 8.1.11 is a pre-check utility, which is a configuration validation utility. And what it does is validate the Linux mount proxy environment for Hyper-V file restores. This is going to be a script, and the script goes out there and checks the operating system support, the CAD status, firewall CAD status, libssh2 status, iSCSI status, and the status of all of the daemons that support file restore, Hyper-V file restores on this Linux mount proxy. Invoking the script is pretty easy. Basically, you're just going to go to the scripts directory and run the precheck.sh. And it's going to give you messages and status on the guidelines for any of the required tasks that are necessary to ensure that the configuration is running. As you can see in all of the slides that we have YouTube videos for, you'll see a link in the bottom, and you can either search in Google or click on the link to get to a video of that feature. Continuing with Spectrum Protect for VE, data protection for VMware, we have introduced in 8.11 support for this new VDDK 7.6.7 query allocated blocks function. What this does is it retrieves a list of allocated blocks of disks instead of the change blocks from this query change disk areas call. So basically, although this was new in the VDDK version 6.7, it's also going to work against vSphere version 6.5 and 6.0. And what this feature is going to allow us to do in version 8.1.11 is to reduce the amount of data that is being backed up using Spectrum Protect for VE and CBT using this CBT vSphere API. There is no extra configuration required on the Spectrum Protect side. It just works, and basically the backup of VMs on thin desks will be smaller after data is deleted inside a virtual machine. Now, just an additional piece of information here. The backup time may be reduced due to the parallelism during control file backups, but more free space for the control file cache might be required due to that parallelism. We have a quick example here. I'm not going to read the numbers. I'll let you read the numbers during when you review this presentation if you're interested in this feature. But here we have a VM that is filled to 200 gigabyte. It has a 200 gigabyte thin disk that has 150 gig used. And then we went in there and removed 100 gigabyte of data from the disk and added 40. And here you can see a change from the amount of data that is backed up in 8.1.10 and 8.1.11. In 8.1.10, in this particular scenario, you might back up 100 gig to 140 gig. But in 8.1.11, that number is only around 40 gig. So you can see that there's a significant savings when using this function with Spectrum Protect for VE. So continuing with Spectrum Protect for ERP or Enterprise Resource Planning, there have been some changes in the interface for SAP. SAP HANA has introduced a new interface for their Backint utility, which is called version 1.5. That interface was introduced with SAP HANA SPS 05. And there have been some differences in the size of the objects that are now passed in the interface, and also a new backup level for the metadata. To net this out, we do support version 1.0 and 1.5 of the Backint interface on both Power Little Indian and x86 operating systems, and we've also gone through and formally certified our product with SAP. That certification was published on October 22nd of 2020, and it will be valid for 3 years from that date. And as you can see, we have been published here in the SAP Certified Solutions directory. There have been a couple small changes in the configuration for SAP HANA that help improve the configuration. First, beginning in 8.1.11, SAP HANA allows you to use multiple backup sessions per service only when the size of the service is larger than 125 gig. And beginning in SPS 05, we allow you to configure and set this limit. And then we also support, beginning in version 8.1.11, the configuration for tenant databases and the activation of that configuration without a restart. So if you go in and activate a configuration for tenant databases, you will not be required to restart or make any manual intervention. Continuing with Spectrum Protect Snapshot for Unix. With version 8.1.11, we are going to support SVC's file systems using HyperSwap. So HyperSwap is a high availability function available for the SVC family of software. So it's available for all of the arrays that use SVC as a basis. And it provides high availability volumes accessed through two different sites. One site is called the master, the other site is called the auxiliary. And basically, the HyperSwap function provides automatic failover and failback. Now with Spectrum Protect Snapshot, Snapshot Backup and Snapshot Restore will only be allowed on the master site, and also cloning will only be allowed on the master site. We do not allow that setup on the auxiliary site for some technical reasons associated with HyperSwap. So we do recommend that you configure at least two device classes, which is the configuration file for Spectrum Protect Snapshot, one for the master site and one for the auxiliary site in the event those two roles change. You can change the device class that's being used for your backup, restore, and cloning. I'm now going to turn it back to Tricia.
Okay, thanks, Sean. Moving on to Spectrum Protect Plus version 10.1.7. I'll be covering the container enhancements, and then I'll turn it over to Sean to cover the rest of the Spectrum Protect Plus enhancements. So Spectrum Protect Plus version 10.1.7 is really exciting for all of the new enhancements in container backup. And I'm going to go through and talk about these 6 areas of enhancement. The first and second enhancement deploys Spectrum Protect Plus server into a container. Then I'm going to talk about our OpenShift support. Then we'll look at how to protect a cluster, namespace, or label. So this will be both the PVCs as well as the resources. We'll then look at restoring to an alternative cluster, number 5. Then we'll look at supporting additional storage in the container. Now, one thing I want you to note on these deliveries is because we have to work with OpenShift and their release schedule, any of the features that depend upon OCS 4.6 inside of Spectrum Protect Plus, those will come out on November 20th as non-production items, and will switch to production once OCS 4.6 GAs. Also, we will switch to production the CSI snapshot related features when that GAs in early 2021. Okay, so let's get started here. The first piece is our containerization of the Spectrum Protect Plus server. You now have the option to install the Spectrum Protect Plus server as a container using a Red Hat OpenShift certified operator. You do not have to install the Spectrum Protect Plus server into a container. You can still have that out on a VM anywhere in your environment. This is just a new additional option of where you can deploy it. And by deploying the Spectrum Protect Plus server into a container, not only are you going to have easy deployment, you'll be running in the same environment as the data that you would be backing up from inside of that container. So the nice thing about this also is you wouldn't have to have your storage admin provision a separate VM or physical environment to run your Spectrum Protect Plus server in. You would simply run it in a container. The requirements to do this are OpenShift 4.5 and above, and then you need at least 20 gigabytes of memory, 4 CPU, and 434 gigabytes of storage. The install procedure is very simple. You'll simply create a new OpenShift project. You'll add the catalog source. You'll create an image pull secret. And then you'll choose either the Spectrum Protect Plus operator that you see here on the right, or if you have the IBM Cloud Pak for multi-cloud management installed, you could choose our MCM operator. You create a subscription. You then will create an instance of Spectrum Protect Plus, and it will be installed and ready to utilize. If you do install a Spectrum Protect Plus server into a container, we do have a new way to update that Spectrum Protect Plus server. That'll be from the menu inside of the Spectrum Protect Plus server. You'll simply click this Update IBM Spectrum Protect Plus, and it'll show you the versions that are available. And if you install this inside of a IBM Cloud Pak environment, you'll also have a menu item from inside that IBM Cloud Pak for multi-cloud management directly out to your Spectrum Protect Plus server user interface. And I do have a YouTube that covers these installations, so check that out. Moving away from installing the Spectrum Protect Plus server inside of container, let's look at protecting the PVCs and resources inside of a container. Back in version 10.1.5 and 10.1.6, we introduced the ability to back up the PVCs inside of a Kubernetes environment. With this backup, there is a CSI snapshot that we take of the PVC and that resides in the Kubernetes environment until we then create a copy and send a copy of that snapshot to the Spectrum Protect Plus vSnap. Both that snapshot that's kept in place inside of Kubernetes, as well as the copy that's made out to Spectrum Protect Plus, are scheduled via our Spectrum Protect Plus's SLAs. A restore can occur from either the snapshot version inside of Kubernetes or the copy version inside of Spectrum Protect Plus vSnap. The other thing to remember about this environment is because Spectrum Protect Plus cannot do an agentless install of the BAS namespace that's required to support this snapshot and copy capability, Kubernetes administrator has to install the Spectrum Protect Plus container backup support software into the Kubernetes environment. And this is all going to become important when we start talking about what we now support in 10.1.7. So let's go to that. The fourth enhancement in the containers is going to be the resource set backup. Previously, we were able to back up the PVCs. This was in SPP 10.1.6 and 10.1.5. And now we've expanded to back up the resources. And these would be both your namespace scoped and your cluster scoped resources. And this is going to provide a holistic protection of your containerized stateful applications. And it's going to protect the infrastructure and cluster components and provide recovery in the event of a disaster. Now, the application can then be restored from scratch without doing extensive manual work. And we'll talk about exactly what scope this DR provides and what you would still need to do if you had a complete failure of your clusters here in a few slides. In order to holistically protect these containerized projects or applications that are running inside of Kubernetes or OpenShift, you've got to be able to protect the PVCs, and then you've got to be able to protect the metadata or resources in addition to that. So we have to enable the resource protection during the install of the Spectrum Protect Plus container backup package on both Kubernetes and OpenShift. So you're going to have installed Valero. And then when you install Spectrum Protect Plus, you'll need to specify the Valero namespace, which we'll call spp-valero as default in the configuration files. And as part of this, we will then deploy an object store called min.io into the BAS namespace, and this will be linked with Valero and utilized to capture the tarred and zipped files that have the information about the resources in them. And then when we do a copy out to Spectrum Protect Plus vSnap, we will then take these tarred and zipped files out of the min.io and send a copy to the Spectrum Protect Plus vSnap. I'll also talk about how you can use labels to organize the data protection management. So if you do have multiple applications running inside of a single namespace, if you have labeled all of those applications appropriately, as well as the resources, you could protect by a label instead of by a namespace. I do have a video out there that shows the protection and the restore, so be sure to check that out. So some of the use cases that are now available is you could just protect the resources. And this would be a very cheap backup because when you protect the resources, they're very small zipped and tarred files that are created. And so you could do this on a frequent basis. Or you could do what we did in previous versions and just protect the PVCs. That would be the volume data only. And remember, when we talk about protecting these resources, you also have two options. You have the snapshots and the tarred and zipped files that are being sent to min.io directly in the clustered environment. And then you have the copy of those that are being sent to the Spectrum Protect Plus vSnap. So we're actually talking about two copies of those and the option of dictating how often the snapshots are being taken versus the copies to the Spectrum Protect Plus environment. So you could do that namespace level backup of your resources and PVCs, or you could even take it a step further and do a cluster backup of all the resources and PVCs inside of your environment. The next few slides might be redundant to people who are already familiar with OpenShift and Kubernetes, but this is just kind of a level set for those people new to it. The first thing I want to talk about is different levels of resources. So here I have this cluster out here, and you can see inside of this cluster I have my master rules, which would have a lot of the information that would be specific to controlling and managing the components of that cluster. So that's here on the left-hand side. And then I have two specific namespaces that are probably dedicated to specific applications. And if we look at this namespace DB2 test, inside of that, we have our pod, which would have the applications running files as well as the different resources that go along with that. So the green portion here is going to be called a namespace scoped resource. So that namespace in our case is DB2 test, and these are the resources specific to it. Now those resources work in conjunction with cluster scoped resources, which you see here in blue. So for instance, we had a PVC inside of our DB2 test, which works in conjunction with the PV out on the cluster scoped namespace. Over here on the left, then you see our etcd, which is going to be our key value store, and it's going to protect the artifacts that are describing the resources. And this is going to be what we're actually working with to protect when we talk about protecting those namespaced and cluster scoped resources. So I want to be specific about how Spectrum Protect Plus defines a cluster backup and disaster recovery. So we are going to provide protection of the cluster resources as they are deposited into the etcd database here. And so this is not going to just be an opaque dump of the etcd. We're actually going to do a refined backup of that, creating those tarred and zipped files that will be sent to min.io. We're also going to protect the persistent volume data as supported by our Spectrum Protect Plus container backup support application in the BAS namespace. And that would be the PVCs that are supported either by the CSI-based Ceph block storage, known as RBD, or new with 10.1.7, the Open Container Storage, which is the OCS block storage, or virtualize and scale. Spectrum Protect Plus's protection of the cluster backup does not include the Kubernetes system components and its configurations. This is like the control plane components, or the kube LET, the kube proxy, or the container runtime. It's not going to be any of the artifacts that are outside of the Kubernetes environment, for instance, non-CSI volume drivers or node-related network components and configuration. And it's also not going to be the operating system of the nodes. So if you look at this picture here, Spectrum Protect Plus is able to protect the colored items, but doesn't cover the gray items. So if you had a complete disaster of your cluster where everything was lost, the first piece you'd have to do is set up your hardware or virtual machines and set up the operating systems for each of those nodes. Then you would have to go out and provision and configure the Kubernetes or the OpenShift control plane, and this would include installing any of the non-containerized add-ons like the non-CSI based volume drivers. On top of that, you would then need to reinstall the Spectrum Protect Plus container backup support application, which gets installed into the namespace of BAS, as well as Valero, which would be installed into the Spectrum Protect Plus Valero namespace here. And at that point, then the clusters would be registered automatically into Spectrum Protect Plus. You could then go out and do the restores of, for instance, your production namespace and your test namespace that might have been backed up to Spectrum Protect Plus. If it was just a normal restore to a different cluster, then you're kind of starting at this point, and then you can choose your namespaces that you want to restore out to the different clusters. So Spectrum Protect Plus is dependent upon Valero or the OpenShift OADP installation of Valero in order to protect the resources. Valero is an emerging open source solution, and it's established as a standard inside of OpenShift with the OADP implementation. And Red Hat also provides extensions to Valero and the OADP via plugins. So it will protect all the cluster resources, including the custom resource definition, CRDS. And it can actually protect persistent volumes, but in the Spectrum Protect Plus implementation, we are not using the Valero capability to do that. Instead, we're using the capability built into our BAS functionality. We integrate Valero into Spectrum Protect Plus, not vice versa. So the Spectrum Protect Plus user does not need to get directly in touch with Valero, doesn't have to use the command line or anything else. The interaction is going to be managed by Spectrum Protect Plus. We do support version 1.4.2, 1.4.3, and 1.5.1. And in order to utilize Valero, you are going to have to download it. I have a link right there. Then you'll extract that tar file. You'll then go ahead and change directory into the extracted directory and run the ./Valero install. And when you do this, you do want to specify the namespace as spp-valero. You can call it something else, but for consistency, we recommend calling it spp-valero. This does have to be a dedicated instance of Valero. So if you're using Valero for something else out in your containerized environments, you do need to install a specific instance for Spectrum Protect Plus. And if you didn't install it when you originally installed your Spectrum Protect Plus solution, you can go back and update the BAS values YAML file and do your Valero install. Now, OADP is going to be your OpenShift application data protection operator. It does have a different install path. You can see that here in this graphic. There's a good video out there about installing that. And once again, you will want to install that into the SPP Valero namespace. Another component that we rely on in order to do the resource backup is the min.io and its PVC. And min.io is an object store used as a target backup location for the Valero backups. So Valera will send the zipped and tarred resource definitions out to our MinIO in its connected PVC. This is actually a very small file, so it's only a few megabytes in size. And this MinIO is going to be part of our Spectrum Protect Plus container backup support package that's going to be deployed into this BAS namespace. It does have a PVC attached to it that is a 10 gigabyte volume. So the default storage class of the cluster is going to be used if you don't explicitly specify the parameter MinIO storage class in the BAS values YAML file. So not every cluster has a default storage class defined, so we really do suggest you explicitly specify it with this option. So what happens is that during what we call a snapshot backup, where a PVC would normally do a snapshot out to locally attached storage, Valera will copy the etcd definitions out to MinIO, tarred and zipped, and keep them there. Then when we do a copy backup out to the Spectrum Protect Plus vSnap server, we take that version of those tarred and zip files out of the MinIO, and we take the local snapshot that was created for the PVC and send them both over to the Spectrum Protect Plus vSnap server. Another thing to know is that underneath the covers we do have a certificate manager. In 10.1.7 we're using the Red Hat OpenShift certificate manager, and that's going to replace BAS-cert-monitor that we used in 10.1.6 and 10.1.5. And all this does is help the communication between the different components inside of the BAS namespace stay safe by utilizing TLS. Also underneath the covers we're using Helm. And Helm is important because it's a package manager. So Helm is going to become important when we do the installation of the Spectrum Protect Plus container backup support. So you will have to install Helm 3 into the Kubernetes or OpenShift environment. And if you already had Helm 2 out there, you will need to rename the executable to HELM3 so that they can coexist. The two things that are important when we go to install the Spectrum Protect Plus container backup support is that we need a Helm package. And this is going to include things like our chart.yaml, our values.yaml, our templates, and our scripts. So this is kind of the how to do it, what to do instructions for installing and updating our code. And then we also need a set of Docker containerized images for the Spectrum Protect Plus container backup support. And so this becomes important that you understand that we have the Helm package and we have the Spectrum Protect Plus container backup support application package. And these two packages might be installed from different locations depending upon the type of install you do. So when we're installing this containerized backup support, you've got two options. If your Kubernetes OpenShift environment is in what we call a disconnected or air-gapped environment, where the Kubernetes or OpenShift environment does not have direct access to the outside internet, then you will use a intermediate download server to pull those two packages that I talked about, the Helm and the SPP images, and they're pulled down as a zipped up package from Passport Advantage, and then we extract those two packages and we install the Helm information, and we take the Spectrum Protect Plus container backup support application pieces and put those out on a local Docker registry so that they can then be installed into the environment. The other option would be in a connected environment, and in a connected environment, the Kubernetes or OpenShift environment will connect directly out to a existing IBM Helm repo server. So this is already existing, already set up by IBM. And it'll pull from there the Helm instructions, and from the entitled registry, it will pull the actual Spectrum Protect Plus container backup support application files to be installed into the environment. Now, both of these, depending on the environment you're installing in, we can do via a command line install, or if you're installing into an OpenShift environment, you could also deploy it with the web console. Now, one of the things that's important, regardless of the way that you're installing this, if it's disconnected or connected environment, is you do have to fill out two critical files. And these files are called our BAS options.sh and our BAS values.yaml file. The BAS options.sh is used to configure the prerequisites, whereas the BAS values is used to perform an install or upgrade. Regardless if this is an OpenShift or Kubernetes environment, you will need to go through and fill in the appropriate values from your environment. Inside of each of these files are hints and tips for both Kubernetes or OpenShift environment on how to obtain those values so that you can run those commands and get the output and then plug them into the correct variables. So if we're looking at installing, for instance, either into a Kubernetes or into an OpenShift with a command line in a disconnected environment, remember this is one where your Kubernetes or OpenShift environment doesn't have direct access out to the outside internet, you're going to pull down from the Passport Advantage this specific package, which contains both your Helm and your Spectrum Protect Plus images. You're going to unpack those, and then you're going to update those two files that I talked about, the BAS options and the BAS values. And then you're basically going to run a BAS install against this, which is going to do the Docker load, create the namespaces, the image pull, secrets, the credential secrets, and the Helm install. And after that, you'll run some checks to make sure that everything installed correctly for the Spectrum Protect Plus container backup support. Now, depending upon if this was installed in a Kubernetes environment or if this was installed in an OpenShift environment, the last step, number 7, will look just a tad bit different with the commands that you're going to issue. Also, the only other change is when you update those two files, they are slightly different hints and tips inside of the files, depending if it's OpenShift or Kubernetes, for obtaining the needed information to plug into the parameters. If you're going to install into an OpenShift connected environment, then you can either use the command line or you can use the OpenShift console. And basically you're going to go through and update your OCP so it refers to an external Helm repo. Then you're going to add in the Helm repo to the local repo list. You're going to expand the Helm packages. And then you're going to go into the OpenShift console. And from the developer view, you're going to create a project called BAS. And remember, the BAS namespace is where we install our container backup support into. And in OpenShift, instead of namespace, we call it projects. Then you're going to create an image pull secret, the credential secret, and then you'll do the Helm install of Spectrum Protect container backup support package. So the OpenShift console install method is just slightly different from the command line method, because in the command line method, you'll just kick off a executable BAS install-entitled versus the OpenShift console method where you'll go through OpenShift console to do the creation of the secrets and the Helm install. Okay, so once you have that container backup support package installed for Spectrum Protect Plus into the BAS namespace out in your OpenShift or Kubernetes environment, you're now ready to start doing the backup of either the PVCs and or the resources for the namespaces that are out there. When you go into the Spectrum Protect Plus user interface, underneath the Manage Protection, you'll now see containers, and then you'll see two options, Kubernetes or OpenShift. So for instance, if you click on Kubernetes, that will take you out there and show you the clusters, and you can drill down in the clusters. In this case, we've drilled down into the Florida Production 4 cluster, and you will now see both the namespace as well as the resources for that specific cluster. Now down here in this little icon here, I show you the cluster scoped resources that the Florida prod 4 resource refers to. So this kind of correlates back to what we talked about earlier. Now, if you were to drill down into a namespace for this cluster, in this case db2-test, we could then see the namespace scoped resources as well as the PVCs listed here. And in fact, that's kind of the green resources here in this little picture. So from the user interface, you can choose what level of resources you want to protect. Do you want the cluster scoped, the namespace scoped, or both of them, as well as the PVCs that you want to protect. And you would assign those to an SLA to do your scheduled backup, both inside of the Kubernetes environment or OpenShift environment, where we're doing that as a snapshot to protect the PVCs, and using Valero with MinIO to protect the resources. And then the copy will copy both the PVC snapshot and the Valero MinIO information over to the Spectrum Protect Plus vSnap. In addition to doing the backup based upon the namespaces, you can also do it based upon labels. So if you go and you click on the view and choose labels here in the user interface and then enter the label, in this case we entered DB2, it will show you the PVCs and resources that match that label. So it's really going to depend upon how your environment is laid out. If you do a namespace-based backup versus a label-based backup, it's possible if you have a very large namespace with many different applications running inside of it, you may choose to do a label-based versus if you have like a dedicated namespace for a specific application. When you look at protecting the resources by label versus protecting PVCs by label, it's a little bit different. For PVCs, either you're protecting them or you're not protecting them. Whereas for each resource item, that resource actually represents hundreds of different items underneath it. And so depending upon the label being added to an SLA policy, a different subset of resources will be considered. For example, if you had a namespace that had 10 resources associated with it, and 3 had been given the label A, but 5 had been given the label B, if you add label A to the SLA, that will only protect those 3. Versus if you add label B, that would protect 5. If you added both of them to the SLA, Valero will do a separate backup for each of those resource labels. And the reason is Valero can't apply an OR logic when it does the protection of its resources based upon labels. So you will see multiple entries then created inside of that MinIO. Of course, you can also do this protection from the command line. And we've added in 3 new request types if you're going in and editing different YAML files. We have a backup resources request type, which will just add the namespace or the cluster scope resources to an SLA, but it doesn't kick off the backup. It would wait for the SLA to actually run that backup. Versus an on-demand backup resources, which would add the namespace or cluster scoped resources to that SLA and kick off the backup. We also have a restore resources request type, which will restore the resources from either a snapshot or the copy backup. Remember, the snapshot backup is inside of the Kubernetes or OpenShift environment, whereas the copy backup has been copied to Spectrum Protect Plus and is resident in the vSnap. So once you've done the backup of your PVCs and or resources, you now have the option to do an alternate cluster restore. So previously, snapshot backups, which remember are inside of Kubernetes, versus the copy backups, which are out on Spectrum Protect Plus vSnap, could only be restored to the same cluster and the same namespace. And now with 10.1.7, you can choose alternate clusters and alternate namespaces for that restore. And so this helps enable data mobility by spinning up those applications into alternate locations, kind of doing a quasi-clone of those applications. And it supports disaster recovery and data reuse for the testing and analytics. So the restore to an alternate cluster is only supported from backup copies in the Spectrum Protect Plus vSnap. It's not supported from the snapshot copies out inside of the Kubernetes or OpenShift environment. And the support for alternate cluster and alternate namespaces is going to be limited to the Spectrum Protect Plus user interface. You won't find that on the command line that I just showed you. So this is what the restore interface looks like inside of the Spectrum Protect Plus user interface. You can see you have these options like, are you restoring from the copy inside of the Spectrum Protect Plus vSnap or from the snapshot out in Kubernetes OpenShift. You then are going to be prompted for the restore method, and this is going to be basically, am I restoring to a new PVC name or am I keeping that same PVC name? And finally, you'll be prompted for the restore destination, and this is where you can choose to restore to the original cluster or restore to an alternate cluster. If you're restoring to a new namespace, that namespace already has to exist. Otherwise, you'd have to go out into Kubernetes and OpenShift and create it and then rerun an inventory for Spectrum Protect Plus to see it. Depending upon where that backup resides, is it a snapshot copy out in Kubernetes, or is it a copy out inside of Spectrum Protect Plus vSnap? That's going to dictate how that can be restored. So here you'll see the different types of restore, where it's supported, and is it supported to an alternate cluster as well. So be sure to refer to this because there are some limitations on where an alternate cluster restore can occur to. A couple other things to be aware of is that we only support restore to another storage class of the same storage provisioner, and we only allow restores of access mode ROX, read-only mini, or RWX, read-write mini. The prior release only supported the read-write once. Threading is added to the restore engine to support parallel restores, and that maximum number of parallel restores is going to be based upon maximum concurrent PVCs. Override of PVCs is not allowed, the same as in prior releases with Spectrum Protect Plus. So the PVC must be deleted if you do want to restore it to the original PVC name. We do support the restore of snapshots taken back in version 10.1.6 on this 10.1.7 Spectrum Protect Plus environment. Okay, and finally in this version we have added support for IBM virtualized storage. So in version 10.1.5 we only supported Ceph block storage, and now we support IBM block storage with IBM virtualized storage. So this will leverage the IBM CSI, Control Storage Interface driver, which will be performing the Kubernetes persistent volume backups and restores of the file system storage. And this will, of course, support both your snapshots locally inside of the Kubernetes or OpenShift environment, as well as the copy out to the Spectrum Protect Plus vSnap. So for this support, we do require OpenShift 4.5 and the IBM Block Storage CSI driver version 1.30, and for Kubernetes we require the IBM Block Storage CSI driver 1.30 also. So make sure you check out the requirements out in our documentation on this. Okay, with that I'll go ahead and turn it back to Sean to cover additional enhancements to the Spectrum Protect Plus product.
Continuing with Spectrum Protect Plus version 10.1.7, I'd just like to recall one of the things we did at version 10.1.6. First of all, you recall that we at version 10.1.6 added support for backing up Windows physical file systems. So with that support, IBM Spectrum Protect can be used to back up files on a Windows physical file system. You will specify the server that you want to back up, and then IBM Spectrum Protect Plus will discover the file systems that belong to that server and provide a UI for doing backup and restore. Well, in version 10.1.7, we've done some enhancements to this particular feature and function that I want to point out to you. First of all, from a scalability perspective, we have enhanced the scalability of this function so it will perform faster, basically approximately 20% faster or 50% if you're doing incremental forever backup. And we now officially support 10 million objects for backup. So the number of files that we can support on a particular file system has gone up considerably. And we continue to do testing in that area. We've also changed the user interface to add some additional features for the user interface. In the previous version, 10.1.6, you couldn't search for files to restore. Now you can. You couldn't write files that you restore, and now you have the ability to overwrite when you do a restore. You also couldn't back up sub-mounted volumes that did not have a drive letter, and with version 10.1.7, you can now do that. We've also enhanced the exclude rules for Windows to include Windows environment variables. So if you want to exclude a Windows environment variable from your backup, you can do that by referencing it with percentage signs. Just continuing, there are some limitations that were there in version 10.1.6 that are still there in 10.1.7, and we may at some point remove those restrictions, but as of version 10.1.7, they're still there. Today, we don't support Microsoft cluster volumes, file allocation table file systems, the backup of HSM Windows stub files. We do not support a retry mechanism using VSS snapshots. So if a file changes while you're backed up, we're going to support that via retry. We also do not support concurrent agents on our Windows physical system. So if you're using one of the agents or one of the Spectrum Protect Plus features that protects Windows applications, you cannot do a file system backup at the same time. Finally, each system that you back up with Spectrum Protect Plus must have a unique UUID. And the way you can end up with a non-unique UUID is if you clone a system in VMware, for example. So just understand that you do have to have a unique UUID in order to back up a physical Windows file system. So continuing on with Spectrum Protect Plus version 10.1.7, we have now enhanced the way that we are supporting vSnap on Spectrum Scale. With regard to Spectrum Scale, we wanted to produce a solution that meets our customer requirements and allows our customers to reuse their ESS investment with IBM Spectrum Protect Plus by running vSnap on that hardware. The solution that we had to do this in the past involved having an NFS data store. And in many ways, that was not an optimum solution because of the overhead required to present the storage in that way. So beginning with version 10.1.7, we are now going to support running Spectrum Protect Plus with Spectrum Scale and allow the storage to be presented directly to the vSnap server. So we are going to eliminate the need for an NFS data store virtualization. We also are going to eliminate the need for a vSphere prerequisite for using ESS storage. Now, the documentation for this is not currently at 10.1.7. At some point, we are going to add it to the Knowledge Center, but for the moment, you will find it in a tech support document. So if you just Google for vSnap on Spectrum Scale, it should show up when the product goes to general availability, when 10.1.7 goes to general availability. There are some prerequisites for doing this. We strongly recommend, as with all cases, that you follow the IBM Spectrum Protect Plus blueprints to meet the system requirements for the vSnap in terms of CPU, memory, network connections, and the planned vSnap server capacity. So there is a very good sizer for Spectrum Protect Plus that lets you do that. and it allows you to determine the CPU and memory requirements for running a vSnap server on a piece of physical hardware. We do recommend that you add an extra 8 gig for the scale paging pool, and also note that there are some requirements for the versions of Linux that you use to host the vSnap. Red Hat Enterprise Linux version 7.7 or later, and IBM Spectrum Scale version 5.0.5.1 or later. Note that at the moment, Red Hat Enterprise Linux version 8 is not supported. And this is some information about how the setup and configuration is going to work. As a general rule, you're going to set up IBM Spectrum Protect as you would usually using the blueprint sizer. You're going to install an IBM Spectrum Scale cluster and file system as usual, and then you're going to mount the file system on Linux compute nodes using large image files. And then the IBM Spectrum Protect Plus vSnap is going to be installed on the NSD client or server using the image files as a loop backup device. Now that's a very high level description. Here you can see a picture of the architecture. If you're going to implement this configuration, what I would suggest you do is take a look at the white paper that has been written and available on our support site to give you the detailed configuration and the details of exactly how you would configure Scale and Spectrum Protect Plus vSnap. Okay, so continuing with Spectrum Protect Plus version 10.1.7, we're going to delve into quite a few smaller enhancements that are part of the core technology of Spectrum Protect Plus that were added in 10.1.7 or earlier perhaps, but I just wanted to point them out to you. Let's start with this scheduling days of the week. There was an efix distributed in version 10.1.6 that when an SLA runs weekly, you are now able to pick the days of the week on which it runs. So for instance, if you wanted an SLA to run on, say, Monday through Friday, you can now do that when setting up the SLA. Continuing with 10.1.7, we have made some changes in the controllability of load balancing for vSnap and VADP proxies. Beginning in 10.1.7, we've added a slider that allows you to determine how new VMware backup data is allocated to the vSnap servers in your environment. And as you can see here, you can do it by VM count or by free space. Now, the recommendation is to go with the default unless you're experiencing some problem with the allocation or maybe you want to make a temporary adjustment. And our recommendation is to do that when you work with IBM support if for some reason you want to make a temporary adjustment. Otherwise, go with the default. Just some details on how this works. The vSnap storage balancing determines the initial placement of the VMs, and this decision happens during the first backup, and all subsequent backups will go to the same vSnap server. So if there are multiple vSnap servers in the environment, Spectrum Protect Plus will balance the placement of those virtual machines across the vSnap servers based on the load balancing algorithm. That algorithm takes into account storage size of the vSnap servers and the count of the VM on each vSnap server. Continuing, we've added a feature to do a production restore with disk replace. This is a new restore method that will show up on VMware, and you can see it over here highlighted. And what it does is let you use an existing virtual machine, but replace the disks by those from a previous backup. So really it preserves all of the configuration information for the virtual machine aside from the storage. There is a requirement that the VM must be powered off, and it can only be restored to its original location. And certain features are not available when doing a production restore, such as overwrite a VM and restore tags. Beginning in version 10.1.7, we now allowed you to exclude resources based on associated VM tag. Again, that can be seen in the configuration option. So here you can go ahead and specify tags for which you want to exclude the resources for. Continuing with some enhancements to the core technology, we've added some report types for Microsoft 365, Office 365. That includes the backup history report, the SLA policy RPO report, and the protected and unprotected users for Microsoft Office 365. Those are very similar reports to what we have for other platforms, so you can see now they're available for Office 365. We've also enhanced the container backup utilization report, which allows you to select Kubernetes or OpenShift, one of the two big platforms that we've added for this version of Spectrum Protect Plus. Beginning in version 10.1.7, we have removed the local vSnap server from the SPP server download. So if you download the local vSnap, it's going to be no longer included with the OVF that is included when you download the Spectrum Protect server. This was really designed to be used for proof of concepts, and so hopefully if you're running in production, you are not using this. If you are, what you'll have to do is migrate that data from the vSnap to a standalone vSnap server. And the documentation is included in the Knowledge Center that allows you to migrate that data to a standalone vSnap server. Continuing with the theme of deprecation of the attached vSnap in the Spectrum Protect Plus appliance, there was also a user associated with that vSnap server called the local vSnap admin. And with 10.1.7, that local user has been completely deprecated. We will not allow you to use it anymore. If you do attempt to use it in the user interface, you're going to get an error message that you see below. And when you update the vSnap to the associated version with 10.1.7 through the CLI, you're going to get a message that says you need to remove that identity and then use another identity to access that vSnap. So you can either use server admin or a vSnap user that you create in the vSnap using the vSnap user create command. Continuing with deprecation of the demo policy and site. Beginning in version 10.1.7, we will no longer deliver the demo policy. That was designed to be used with a POC, and what we found is, although a lot of people were using it for POCs, they were also moving to production, and in many cases it was not suitable for production use. So beginning in version 10.1.7, we're not even going to deliver the demo policy. If you want to do a POC, you should use one of the included bronze, gold, silver, or EC2 or container SLAs that are delivered with the product. Continuing with the server admin user account that's used on both vSnap servers and the Spectrum Protect Plus server. In previous versions of the product, we had a failed attempt lockout policy and password expiration policy enabled by default. This was to promote security in the Spectrum Protect Plus server, but in some circumstances it resulted in situations where the server admin account became locked and the user was locked out of the system. So beginning in 10.1.7, the default is going to be to remove both of those policies. You can, however, choose to opt into the policies by referencing the documentation in the Knowledge Center. If you should decide to apply the more restricted password policies and end up locking the server admin account, we've also added a topic to the user guide to walk you through the procedure of resetting the server admin account password. Continuing with some minor vSnap changes, there were certain circumstances where the vSnap server storage pool could fail to import during the startup processing prior to version 10.1.6. Beginning in 10.1.7, the startup procedure for the vSnap server has been modified. So if the storage pool fails to import, the vSnap data service is marked as failed and the other vSnap services do not start. This results in a state where the vSnap server is unreachable and appears as offline in the user interface. So it allows you to realize that the server is offline and go ahead and take corrective action. There's been some changes to the administrative console in Spectrum Protect Plus 10.1.7. Certain functionality that was previously found only in the admin console has been moved to the regular GUI, and that's the Manage SSL certificates and the upgrade the license from a trial version to a full version. You can also reset the super user or the admin account from the admin console. Just a note, if you are running the containerized version of Spectrum Protect Plus that Tricia spoke about, you will not have an administrative console. Continuing with the changes to 10.1.7, we now have 3 slides of global preferences changes. I won't read most of these to you. I'll let you reference them in the slide deck. Many of these are settings that are perhaps used by support or used in case you have some error. So for instance, the maximum retry timeout for WinRM, index overflow settings, removing unselected VMs from SLA, automatic removal of stale catalog entries, redoing the replications for VMs and volumes that have already been replicated. Perhaps the auto logout timeout is one you might want to change if you go in and look at these. And then finally, the default groupings for number of VMs in a group. So again, for the most part, these are going to be set at the direction of support. If you need to change them, I would recommend you consult with support, except for the simpler ones, shall we say, like perhaps the auto timeout. Continuing with some documentation updates, we continue to update the documentation, and we have a new or continue to add information on the REST API because a lot of people are interested in using the REST API to control Spectrum Protect Plus. Again, you can access the API reference from either the Knowledge Center or from within the product. And then finally, as one last thing, we did release with this release an updated version of Spectrum Copy Data Management that is currently 2.2.12. And in this version, we added support for pure CloudSnap and active clusters. We added support for HPE Nimble Storage, and we also added the ability to protect ACFS Oracle workloads on both Linux and AIX. That completes this update. I hope you found this information useful, and I look forward to seeing you again for the next update of Spectrum Protect and Spectrum Protect Plus.